Hello, grade 7. We are beginning chapter 5. You need your book and your notebook, and I would have your ruler and protractor available. Chapter 5. Oh, you also need your book, your math book. We're going to turn to page 1, and we're going to talk about angle properties and straight lines. That is the title of this chapter. So we are starting geometry. Yay! So, can you make that basket? In basketball, the launch angle has a big effect on a player's chance of scoring. The launch angle is the acute angle the ball makes with the floor when the ball leaves the player's hands. The release point, or the distance the player's hands are from the floor when the ball is released, also affects the chances of scoring. Studies have shown that successful scorers tend to have a relatively high launch angle and release point. In this chapter, you will learn about various angle relationships. So, you guys have been playing basketball in your PE class. So, who knew that geometry, math, was a part of basketball? Miss Allie did. All right. So, as we think about angles, this chapter, we're going to think about what are some special properties formed by angles on a straight line, angles at a point, and parallel lines and a transversal. Looking at this, what are some words that we have heard before? You don't have to write any of these down because we're going to talk about them, but you guys have heard angles before, and you know what parallel lines are. Some new words might be like transversal, properties. We've not used the word properties when talking about math, but we are going to learn more about that. So, what are some things you know about angles? Again, you don't have to write them down, but angles are measured in degrees. Do you guys remember that? Does anyone remember? Do you remember how many degrees are in a triangle? If you said 180, give yourself a pat on the back. Do you know how many degrees are in a circle? If you said 360, give yourself another pat on the back. Okay? And so these are all things that we will use in this chapter. We'll also talk about some different kinds of lines, parallel lines, perpendicular lines, and different kinds of angles and triangles. So lots to look forward to. So let's dive in. So remember when we're taking notes that you need to write everything that's in blue or any other color other than black. If it is written in black or it is typed, you do not have to write it. Okay, so we are recalling prior knowledge of for chapter 5. Okay, so things that we've learned in the past. And we're going to look at classifying angles. Okay, so an angle is formed by two rays that share a common endpoint called a vertex. Okay. And so two rays, remember rays have a start point and end point, and they keep going, and they can go on forever. Okay, so this angle down here is formed by ray QP and ray QR. Okay, and they share a common endpoint called a vertex, which is this one. They have it in common. When I said ray QP, it started at Q. When I said ray QR, it started at Q, which tells me that that is the vertex that they share. Okay, And angles can be named by letters or numbers. It's very common that we name angles based on the letters that form the rays, right? So we have, it can be named angle PQR, which means we started here, QR, or it can be named RQP, which means we start here. But you'll notice that the middle number or letter of each of these is Q, because that is the common endpoint that they share, the vertex. If you were to say PRQ, the angle would go this way. Okay. You could also just call this one angle Q. If there's no other letters around it, no other lines, it can just be angle Q. And remember that this is our symbol, like a slanted, looks like an angle, is our symbol for angle. Okay. Remember, if you need more time to write the notes, you can pause the video. All right. So angles are measured in degrees. Measured in the degrees. And degree is written as a little zero, little open period, but up. Okay. So you'll see it written like M angle Q equals 45 degrees. Okay. Now you'll see this M angle Q or M angle. This means measure. So M angle Q equals 45 degrees means the measure of angle Q equals 45 degrees. Okay. This is a big part of our lessons this chapter. Okay. And so you can classify angles according to their measures. You remember the name of this angle? I hope you said it is acute because it's a cute little angle and it measures less than 90 degrees. Okay? And so any angle that measures less than 90 degrees is called an acute angle. Okay? Let's go to the second one over here. This one should be easy. We've been doing this for a while. This one is called a right angle because it measures exactly 90 degrees. Okay? It can only be right if it measures 90 degrees. If it measures 89, it is acute. If it measures 91, it becomes our next angle. Okay? Our next angle is called an obtuse angle, and it measures greater than 90 degrees, but less than 180, because if it measures 180, it is no longer obtuse. It is a straight angle. Now, if it measures greater than 180, we also call it an obtuse angle. But if it measures 180, it is not. So a straight angle measures exactly 180 degrees. Okay. Once you have all of that written down, you can turn to page 2 and you can do quick check numbers 1 to 6. Pause this video and come back and check your work. So for quick check, number 1, you should have right because it has a 90-degree angle. Number 2 is acute because it has a 60-degree angle, which 60 is less than 90. Number 3 is an obtuse angle because it measures 154 degrees, which is greater than 90 and less than 180. Number 4 is a straight angle. It measures 180 degrees exactly. Number 5 is acute because the measure of angle W is 86, which is less than 90, and measure of angle Y for number 6 is 90, which makes it a right angle. If you got all 6 of these right, give yourself a star. And we will move on to identifying parallel and perpendicular lines. So, identifying parallel and perpendicular lines. The two lines in the same plane that do not intersect are called parallel. Okay, and this means that they are always the same distance apart, no matter which point you choose on this line, because remember, lines can continue going forever. That's why they have an arrow. If you chose any point on this line, it would be the same distance from this line. Okay? And so we say that AB is parallel to CD. And because we all like shorthand, especially in geometry when we start writing this a lot, we can say AB is parallel to CD. Okay? And you'll also notice that in our drawings, and what you can do is we denote parallel lines in pictures with an arrow pointing to the right. It might be pointing to the left sometimes, depending on where it is. But if you see arrows like this on a line, it's telling us that these lines are parallel. Okay. If there are two sets of parallel lines in a thing, they might add another line to differentiate between the two sets. Okay. And then we have when two lines intersect at a 90-degree angle, right? And this is 90 degrees all around. They are perpendicular to each other. Okay? And so this tells us that PQ is perpendicular to RS because they form right angles. Okay? So, now, it might not always look, just because it looks like it is perpendicular, it is not perpendicular unless it tells you that they are perpendicular. And so I am telling you that PQ is perpendicular to RS. Or if you see a line that intersects another line and the box is drawn for you, that also tells you that it's perpendicular. So PQ is perpendicular. Here's our symbol, our shorthand for geometry is perpendicular to RS. Okay. Once you have that written down, you can pause this video and go to the quick check on page 3, do 7 to 11. Come back and check your work. So you should have had that RS is parallel to UT, and you can see that it is denoted with our angles. In number 8, you had two sets of parallel lines. This is what I was talking about, like WZ is parallel to XY. So they used this symbol. But XY is parallel to ZY. And they used two symbols to let us know that it's these two lines that are parallel. Because if you use this symbol on all of them, it would say that all of these lines are parallel to each other, and that is not true. So these lines, YZ and XY, are parallel to each other, and YX and ZY are parallel to each other. So there are two sets of parallel lines. Okay, number 9, perpendicular. AB is perpendicular to CB. And again, you could put BA is perpendicular to BC. The order of the letters here don't matter, as long as it's a point of the line segment. So AB is perpendicular to CB, CB is perpendicular to CD, CD is perpendicular to AD, and AD is perpendicular to AB. There are 4 sets of perpendicular lines, and we know that because there are 4 right angles. Okay? Also because we know that they're right angles because it tells us that it's a rectangle. Okay? In number 10, we have EG is perpendicular to EF, and it tells us because there is a right angle. And then in 11, we have 2 pairs of perpendicular lines, IL and IJ, and then IJ and IK or JK are perpendicular to each other. And then our last part of the day is identifying right isosceles and equilateral triangles. We've done this before. Okay, you've seen all of these triangles. So you do need to draw these in your notebook, but let's look at this first one. Okay, so this first one is a right triangle because it has one right angle as shown here. Okay, now that is all that is needed to classify a triangle as a right triangle is one right angle. So triangle ABC, which this is our symbol to tell us triangle. Okay, triangle ABC is a right triangle. One of its angles is 90 degrees. And that is it. Okay. In our second one, we have triangle PQR. This is an isosceles triangle. Okay. And in an isosceles triangle, the angles opposite the equal sides, so these two sides in an isosceles triangle are equal. Okay, which is why there are lines to let us know that those two sides are equal. So the angles that are opposite the equal sides, okay, so this angle is opposite this side, and this angle is opposite this side. They are also equal. So triangle PQR is isosceles, and that tells us that PQ is equal to PR. So you can write equal to here. We also use the term congruent. Okay, so this symbol means congruent. Okay, which you also might see in your notes or in your homework. Okay, so congruent just means equal. Okay, means the same size. Okay, so PQ is congruent to PR, and angle Q is congruent to angle R. And that is true for every isosceles triangle. All right. And then our last triangle, XYZ. This is an equilateral triangle. What do we know about the word equilateral? It has the word equal in it. So this triangle has 3 equal sides and 3 equal angles. Right? So this side is congruent to this side, which is congruent to this side. They're all equal to each other. And this angle is congruent to this angle, which is congruent to this angle. So triangle XYZ is equilateral. And line XY is congruent to line XZ, which is also congruent to line YZ or ZY. Okay? And angle Y is congruent to angle X, which is congruent to angle Z. And this is true for all equilateral triangles. When you have these notes written down, you can do your quick check on page 4, number 12. Pause this video and come back and check your work. So you should have classified your triangles. A, we know that it has two sides that are equal, which makes it an isosceles triangle. Triangle B has a 90-degree angle, which makes it a right triangle. And triangle C has two equal sides and a right angle, so it's a right triangle and an isosceles triangle. The right angle makes it a right triangle. The two equal sides make it an isosceles triangle, so it can be both. D has all equal sides, which makes it an equilateral triangle. E has all equal angles, which also makes it an equilateral triangle. And in F, we have two angles opposite two sides that could be equal. Because these are equal, that means these sides are equal, which makes this an isosceles triangle. If you got all of those correct, give yourself another star. Once you have finished